Find a cubic polynomial with the sum of the product of its zeros taken 2 at a time and the product of its zeros as 3, -1 and -3 respectively. Solution. A cubic polynomial, say f of x, is of the form ax cube plus bx square plus cx plus d and can be shown with respect to its relationship between roots as f of x is equal to k x cube minus sum of roots into x square plus sum of products of roots taken 2 at a time into x minus product of roots, where k is any non-zero real number. Here given is sum of roots is equal to 3. Product of roots taken 2 at a time is equal to -1 and product of its root is equal to -3. Substituting this in the above equation, we get the cubic polynomial as f of x is equal to k inside the bracket x cube minus 3 into x square plus -1x minus inside the bracket -3. Therefore, f of x is equal to k inside the bracket x cube minus 3x square minus x plus 3, where k is any non-zero real number, isn't it? If the zeros of the polynomial f of x is equal to 2x cube minus 15x square plus 37x minus 30 are in AP, find them. Solution. Let the zeros of the given polynomial be alpha, beta and gamma. 3 zeros as it's a cubic polynomial, and given the zeros are in arithmetic progression. So let's consider the roots as alpha is equal to p minus q, beta is equal to p and gamma is equal to p plus q, where p is the first term and q is a common difference. From given equation f of x, a is equal to 2, b is equal to -15, c is equal to 37 and d is equal to -30. That implies sum of roots is equal to alpha plus beta plus gamma is equal to p minus q plus p plus q is equal to 3p is equal to minus b by a. Substituting the values of a and b from equation, which is equal to minus inside the bracket minus 15 by 2, which is equal to 15 by 2. So calculating for a, we get 3p is equal to 15 by 2. That implies p is equal to 5 by 2. Product of roots is equal to p minus q into p plus q is equal to p into p square minus q square is equal to minus d by a. Substituting the values of d is equal to minus 30 and a is equal to 2 from equation, we get p into p square minus q square is equal to minus into minus 30 by 2 is equal to 15. That implies p into p square minus q square is equal to 15. Substituting the values of p, we get 5 by 2 whole square minus q square is equal to 15. That implies 5 into 25 by 4 minus q square is equal to 30. That implies 25 by 4 minus q square is equal to 6. 25 minus 4q square is equal to 24. That implies 1 is equal to 4q square. So q square is equal to 1 by 4. Therefore, q is equal to 1 by 2 or minus 1 by 2. Taking q is equal to 1 by 2 and p is equal to 5 by 2, we get alpha is equal to p minus q, beta is equal to p and gamma is equal to p plus q. Alpha is equal to 5 by 2 minus 1 by 2. Beta is equal to 5 by 2 and gamma is equal to 5 by 2 plus 1 by 2. Alpha is equal to 2, beta is equal to 5 by 2 and gamma is equal to 3 are the zeros of the polynomial. Similarly, by taking q is equal to minus 1 by 2 and p is equal to 5 by 2, we get alpha is equal to 3, beta is equal to 5 by 2 and gamma is equal to 2 as the zeros of the polynomial. Teachers can open the door, but you must enter it yourself. Thanks for watching.